Hi everyone, welcome back to another EKS video, and in this video we are going to be learning about IRSA, which stands for IAM Rules for Service Account. So what's IRSA? IRSA is a feature that allows access to your AWS resources on per pod basis, combining the IAM roles and service account. The word per pod basis is important here because it really allows you to give granular permissions to individual pods to access your AWS resources. IRSA allows applications running inside Kubernetes pods to securely access AWS resources. It may be S3 bucket, DynamoDB, Secrets Manager, or any other AWS resource that you can think of without having to manage static AWS credentials or grant overly broad permissions to the entire EKS node's IAM role. So what it basically means is, suppose in the traditional way, what we will do is we'll create an IAM instance profile, which is an IAM role basically, and then you will attach this instance profile to your worker nodes in your EKS cluster. And now all the pods which are running inside these worker nodes will have access to the resources which are mentioned in the permissions. Okay, so let me just show you this in the AWS console. So suppose I have these two worker nodes running here, T2 medium. I'll just open it. Alright, and you will see this IAM role which is attached here. So all the permissions which are mentioned in this IAM role, let me just open it in a new tab. So this IAM role has a bunch of permissions attached to it. So any pod which is running inside this node will have all the permissions which are mentioned here. Alright, this is a good way. The problem with this approach is that you cannot give granular permissions to the individual pods running inside your nodes. For suppose you want to give this pod access to an S3 bucket, that is something you cannot achieve it, because whenever you attach an instance profile to a node, all the pods which are running in that node will inherit all the permissions which are mentioned or which are assigned to the instance profile. So this is where IRSA comes in handy. So this is the approach that IRSA follows. Here we have two worker nodes. What we'll do is we'll create a service account here, and then we'll create an IAM role in our AWS account. We will associate both of them using the annotations which I'll show you in the later part of the video, and then the pod which is using this service account can access all the resources which are assigned to this IAM role here. So here's how it works. First of all, we create a service account in our EKS cluster, which a service account is basically a Kubernetes resource, alright, which is used to delegate permissions. And then we'll create an IAM role in an AWS account with necessary permissions using identity provider. I'll show it in the later part of the video, so no need to worry about it. And then we will associate the IAM role with the service account using annotations. So here's an example how you can do that. So this is a service account, and then you can add this annotation right here, and then you can provide the ARN of your IAM role. By this way, the service account will be able to access all the resources which are mentioned in your IAM role. So what we'll do is, now I'll hop into my AWS account and then I'll show you how we can do it in our EKS cluster. So let's get started. So I am in my AWS account and I already have an EKS cluster created here. And if you want to know how to create an EKS cluster, I'll suggest you to go and watch the second video of the series. So I have my cluster right here. What I'll do is I'll head over to EC2 console. Alright, here I have an EC2 server running, which is called EKS servers. By the way, this EKS server was also created as a part of the CloudFormation template. So I'll just connect to this EC2 instance using SSM, by the way. Alright, so I'm connected to the instance. Now I'll just switch to root. I've switched to the root user. Now what I'll do is I'll add an entry in the kubeconfig file. And how you can do that, you just have to run a command called AWS EKS update kubeconfig. You have to specify the region where your EKS cluster is running, which is AP South 1 in my case, and you have to give the name of your cluster, which is prod. Alright, so it says that the entry has been added in the kubeconfig file. Now I'll just add an alias here, because alias really make our life easier. Alright, now I can just run the commands. So if I run kubectl get nodes, you will see that there are two nodes which are connected to my EKS cluster. Now what we'll do is we'll create a simple pod and then we'll try to access an S3 bucket in our AWS account. So I'll head over to this GitHub repository which is created for this course. I will open this section called security here, and then I'll open readme.md. So this is the file where I've mentioned all the steps which we need to perform in this video. So first of all, we'll create a pod using pod.yaml. So I'll just create a file called pod.yaml and I'll paste this content right here. And then I'll apply this file using kubectl apply -app pod.yaml. Okay, so it says that the pod is created. I'll just do kubectl get pods. Okay, it's in container creating state. Just have to wait for a few seconds. I'll just do -w, which stands for watch, and now my AWS pod is running. Alright, so if you paid a little attention, you will see that the image which is used in this pod is the official AWS CLI image, which means we will be able to run all the AWS accounts once we exec into this container. So what I'll do is I'll just exec into this pod. Alright, I'm inside the pod now. Now I can run AWS S3ls, and you will see unable to locate credentials. You can configure credentials by running AWS login. Okay, what I'll do is I'll just run one more command called AWS STS get caller identity. By the way, I'm running all these commands from inside the pod. Okay, so it says unable to locate credentials. You can configure credentials by running AWS login, because we have not assigned any credentials to our pod yet. So now what I'll do is I'll just create a service account called S3SA. So I'll copy this content and I'll create a file. Let me first exit out of this pod. Okay, so now what I'll do is I'll create a file called service account.yaml and I'll paste it here. I'll apply this file using kubectl apply -app. Okay, so my service account is created, and how you can validate this, just by writing kubectl get service account. You'll see this is the service account that we created just now. Alright, now let's move to the next part. So now what we have to do is we have to create an IAM role with the following trust relationship. There are a couple of ways to do this. You can either do it from the AWS CLI, or you can also do it from the AWS console itself. So what I'll do is I'll just head over to AWS console. I'll go to IAM. Alright, so I'm in IAM page. I'll go to roles and I'll click on create role. Okay, and for the trust policy I'll select custom trust policy for now. Just select this section right here and copy this entire trust policy. You should paste it here, and the moment you paste it here you will see a few errors here, and the reason being we have to substitute a few void values. So what you need to do is I'll just open this here and I'll go to identity providers. I'll open this in a new tab. I'll select this one which is created for our EKS cluster, and I'll copy the ARN of this identity provider and I'll paste it here. Alright, so this part is done. Now we have to substitute this value here, which is called OIDC provider. You will get the same from this page itself. Just copy this part and paste it here. Okay, so once this part is done, all of the errors will vanish and you can just click on next. Now let's search for the permission policies. Right now we don't have any permissions for it, so I'll just click on next. Now we'll just give it a role, and if you see this documentation right here, the role that we have to give is demo IRSA role. So I'll just use this name. Alright, and I'll click on create role. Alright, so our role is created. Now let's see what we need to do. We need to create a permission policy. So this is the permission that we are going to assign to our IAM role. So what I'll do is I'll just copy this, or you can do one more thing. You can assign any AWS managed policy. So I'll just head over to this page. I'll just open the role that I created, which is this one, and for now I'll just add the AWS managed policy for AWS S3. So I'll add this permission called Amazon S3 full access. I'll click on add permissions and the permission is attached. Alright, now let's move to the next part. We have done this part as well. Now we need to annotate our service account. Okay, so what is annotation? Well, let me just head over to my EKS cluster, and if I show you my service account, kubectl get service account S3 service account. So if you see the service account right here, you will see this section called annotations. So what are annotations? Annotations are basically used to modify the behavior of your service account or your resources. So right now you won't see any annotations which are related to IAM role. Now what we'll do is we'll just run this command, which is right here. Okay, but before that, what we need to do is we need to substitute the value for our IAM role here. Okay, so I'll just copy it and I'll paste it in my notepad and I'll substitute the value for my ARN. So I'll go to my IAM role, which is this one. I'll copy the ARN and I'll paste it here. Okay, so this is done. I'll copy it and I'll paste it in the terminal. It says service account demo service account not found. All right, let me just check. kubectl get service account. Okay, it's called S3 service account, my bad. So I'll just rectify the service account name here. Okay, so it says the service account has been annotated. Let's check using kubectl. So if you see, now we have a new annotation here, which is eks.amazonaws.com/role_arn, and we have associated our IAM role with the service account. Now what we'll do is we will just restart our pod. Okay, and how do we do that? Well, I'll just delete the pod. Let me just clear this terminal and I'll delete the pod now. kubectl delete -app pod.yaml. Okay, so it says the pod CLI is deleted. Let's just check. kubectl get pods. Okay, it's in terminating state. Let's just wait for a few seconds. Okay, so my pod is deleted. You can see it here. kubectl get pods. Now I don't have any pods here. Okay, so my pod is deleted. So now what I'll do is I'll just modify the pod.yaml file a bit. Okay, and we'll just tell the pod to use a service account. How we can do that? Just open your file. And here you need to paste this called service account name demo service account. And for the name, I'll just modify it to S3 service account because that's what my service account is called. And I'll exit out of it and I'll apply the file. Okay, so now my pod is created. Let's just check. kubectl get pods. Okay, it's in running state. Now I'll exit into this pod. And how you can do that? Well, I have a command here for this. Okay, so now I'm inside the pod and I'll run this command called AWS STS get caller identity, which will tell you the credentials which are being used. So if you see, now it's giving you the ARN of the IAM role that we created, which is demo IRSA role. Okay, now let's run the command AWS S3ls. So you can see all my S3 buckets are listed here. Alright, so this is how you attach the permissions to your pods using IRSA. So that's it in this video, and I hope you liked it. If you did, please subscribe to the channel and share this video with other people so they can benefit from it as well. I'll see you in the next one. Tata, bye bye.